screen and hear me okay? No audio issues?
Yes,
Yeah.
Muthu.
Okay, very
I'm
good.
good.
Excellent. So, we'll try and say I have slides ready for Route 53 also. So time permitting, unlike last week, we want to just try and be a little bit more disciplined. And last time it dragged for a lot. So we'll try to see if we can speed things up. And Route 53, we will not be able to show the demo, but we'll see if we can cover the concepts. But
Okay.
KMS would be the prime deal for today. So this is going to be the agenda, folks. So we'll have I have quite a few slides for encryption primer, but I'm not planning on spending too much time on it. I'm guessing that you all have some background on this encryption concepts. That in itself is a big topic. If there is enough interest, probably we can have a separate session on that. So following that brief primer, in the primer, I'm kind of going to cover in a high level way about symmetric and asymmetric encryption, because, some level of understanding of at least symmetric encryption is needed for KMS, even though KMS supports both symmetric and asymmetric. For most of the use cases, I think, you can get away with symmetric encryption. So that's why we want to make sure that you all have some background on that, at least theoretical understanding. So in KMS is fairly a simple topic, but it's very important and essential service, which sort of weaves through many other services which offers encryption services, right? Such as S3, starting from S3 to any, EBS and any database security that is needed using encryption services inherently uses KMS in the background. So it's very important to understand at a, at least at a 34,000 foot level, how this service works. So as part of that, we'll try to understand, what are the different concepts, right? Such as envelope encryption, different types of keys, what is CMK, customer master key, the difference between client and server side encryption, and all those things. And we'll wrap it up with a brief demo as to how this whole KMS works. So as I said, a brief primer about symmetric and asymmetric encryption. We'll start with that. So I don't want to bore people. If you're all familiar with this, and we can go straight to the KMS. Is there any appetite to go through the primer, or we can skip that? Even if one of you...
make it quick and go.
Okay. All right. Yeah. So in this slide, all we are showing is, we have a sender and receiver. They want to communicate information in a secure way. So symmetric key encryption algorithms offer a way whereby you can actually encrypt a plain text, convert that into an encrypted or a cipher text, and send it to the recipient, send it to the receiver. But the key here is the secret key that you're using to encrypt has to be identical, both for encryption and decryption purposes. So that's going to be the big challenge as well. So the sender and the receiver has to have exchanged out of band ahead of the time the secret key, so that when the sender uses that to encrypt and sends it to the receiver can decrypt using the same key. So the challenge is, obviously, you need to have a secure channel to exchange the secret key. And also another challenge is, it's not a good idea to just use one key, right? You want to have what is called as a session key, so to say. You want to have you want to have unique keys for different flows or transactions that we use, which is not inherently offered by symmetric key encryption. So I have a slide that sort of summarizes, some of the points that we discussed. One of the important thing is, symmetric key size is pretty small, and it's faster compared to asymmetric encryption because of that reason. And you have to make sure you have a good understanding about the difference between the key and algorithms, right? Symmetric key encryption algorithm and keys are totally two different entities. Um, and algorithms are all publicly, available. It's not health secret. The idea is to, have the encryption algorithm reviewed by everybody, and if there are any issues, it can be fixed, right? So that's the goal of it. But the key is something that you want to keep it secret. One other thing is, if the key exchange is not done properly, you are exposing yourself to what is called as this man in the middle attack, right? Again, man in the middle attack, uh, sort of opens up, if two users are communicating, um, what happens, it's not like a passive eavesdropping or passively sniffing for some information. So this person can actually insert him or herself in between those two users and start to impersonate. In this example, the man in the middle attacker can impersonate user 2 as user 2 to user 1 and vice versa, which poses grave danger, right? So when the key exchange is happening, if the man in the middle attacker gains that, then I think it's game over scenario, right? So the attacker can communicate between user 1 and user 2, and get all the information that he or she needs. So asymmetric encryption, key encryption, kind of solves the problem in some fashion, but we'll see. In what way. I think it lacks certain things. So in this case, what happens is, we have the same scenario: sender and receiver. They want to communicate in a secure way. So asymmetric key encryption algorithm works in the notion whereby each user would have a pair of key, as part of the key algorithm initialization. Each user has to generate the key, and as part of that, they would be given a public and a private key. So the way the encryption decryption works is, the sender or receiver, whoever creates the key, they keep the private key as the secret key to themselves, and the public key can be published to anybody or everybody. In this case, the sender creates a pair of key, keeps the private key to himself, shares the public key to the recipient. Likewise, the recipient also does the same thing. So now both of them keep their own private key, but they have access to the other party's public key. So now what happens is, the sender wants to communicate to the receiver. So he takes the receiver's public key and he encrypts the message and sends it to the receiver. The keys are mathematically related. The public key and private key pair that gets generated as part of the algorithm when you initialize and generate the key. So the sender now has encrypted the message using the receiver's public key. So now the receiver receives the cipher or the encrypted message, and he is the only one who has access to his own private key, and that's what he would use to decrypt it. So this sort of helps to solve the problem of having to exchange a session key, right? But you really need to make sure that in this case, if the receiver is being impersonated by somebody, and if somebody dupes and sends that public key to the sender, and the sender, if incorrectly assumes that the actual, the intended receiver, um, is the one who has sent it. Now you have a situation whereby the sender is happily encrypting and sending the encrypted communication to, somebody, who's not really trusted or authenticated, right? So that's a problem that asymmetric key encryption, uh, poses, and that can be solved using other techniques like digital signatures and things like that. So with that background, any questions? I'm going to go quickly to the KMS now because I have some other slides that probably you all can go through it offline, which gives more information. Any questions on the basics of symmetric and asymmetric key encryption? Okay, as long as you have good understanding of at least symmetric key encryption, right? I think that should be a good start to have the KMS covered. All right, so I'm guessing that you're all good, and moving on to the KMS Services Overview. So the KMS service, as I said in the beginning, it's a very important service offered by AWS, and it kind of um, helps the customer to safe keep and ensure security for their data in multiple ways, at rest, during processing, in transit, and all those things, right? So primarily, those are the three ways that you have to make sure your data is protected: in transit, at rest, and while processing. So primarily KMS addresses how you can protect your data at rest by encrypting the data using symmetric key or asymmetric key encryption algorithm. So the way it does is by providing you with a platform which you can use to create keys, what is called as customer master keys, CMK. So again, this term CMK is bit freely used. Sometimes people use that to refer customer managed key also, that same acronym, but that's not a correct use. So CMK is always a customer master key. So that's one thing that you have to be very clear. You can use CMK to say customer managed key, but make sure you say that or call it out. But in AWS, KMS service, CMK stands for customer master key, and this CMK can either be there are three types broadly. Either it can be customer managed, or it could be AWS managed, or AWS owned. I have a table that will show the differences between those through three types of keys, CMKs. So essentially, what you do with CMK is you create what is called as a, again, before we go there, let me just quickly go to jump to a couple of slides further down, and we will come back to this. Okay, so so when you want to avail the AWS key management services, first thing that you do is you go and create what is called as a CMK from the console or from the SDK or from the CLI. We'll see that that's the first step. When we show the demo, when we see the demo, I'll show you guys how to do that. Assume that you have created your CMK, or you're leveraging AWS to do that by using AWS managed or AWS owned key, CMK. So now what you have to do is, the goal is you want to use the service to encrypt your data. So for that, you need your key. So this is the key that, we kind of talked about when we were covering in the primer, the symmetric key encryption algorithm primer, right? So you basically need a key for that. So AWS KMS infrastructure helps you to provide you with that key. And CMK, the whole KMS, right? It uses what is called as envelope encryption, right? So, meaning you just keep encrypting. Your data key would be encrypted using customer master key, and the customer master key can further be encrypted by another key, and that key also again can be encrypted by another key, and that's why it's called as an envelope encryption or hierarchical key encryption. So in this case, let's assume that we have only a single layer of encryption, right? In this case, what happens is the customer master key generates the data key, but what it does is it provides you not only the plain text version of the key, but it also encrypts and it gives you the encrypted version of the key, right? So when you get the key, when you ask the CMK, the KMS to provide you the data key, CMK provides you with the data key as well as an encrypted version of the data key. So this is a very important thing. We'll tie all these things, with the upcoming slide as to how it is being used when we encrypt the data and decrypt the data. So let me just quickly go back to the slide where we were seeing, right? So now, hopefully you all have some idea as to, what the CMK is, the role of it. As I said, the CMK contains the material. When I say the key material, that's what is used to generate the data key, which should be used to encrypt the data and decrypt it. But the CMK itself will not be used directly. CMK will be used to create something. That something is the data key, which would be used to encrypt and decrypt the data. And you have a variety of options to choose from. Given symmetric or an asymmetric key. When you create the CMK, it will ask you whether you want to have a symmetric key or an asymmetric key mechanism. And once you choose that, then you have a broad range of options to choose from. For symmetric, you can use AES, triple DES, all those things, RC, Blowfish. And for asymmetric, you can have RSA, DSA, ECC and all those things. And these, the CMKs themselves are stored in a very secure environment. AWS calls them as a fleet of hardware security module, HSMs. And even the AWS employees will not have access to those keys. They have designed it such that, when it gets stashed in the HSM, only the customer will have access. And again, the customer can actually define a policy to govern, who in their organization gets to access and what operation they can perform and all those things. So essentially, they provide you an infrastructure and provide you all the controls that are needed to safe keep the keys as well in HSM. And that kind of ensures that only the, the account holder, AWS account holder, can decide who can access and in what way it can be used. And this interaction with the AWS KMS, can be done to some extent using console. But there are certain things that can be done only through the AWS CLI or SDK APIs. And one other important thing is the CMK never leaves the AWS infrastructure, AWS secure HSM fleets or HSM infrastructure. Only your data keys can be actually, you can actually get that out of the infrastructure. Any questions on this? I know this is a little bit of a, for newbies, I think it may be a little over the top or maybe a little confusing, but feel free to ask any questions you may have. So this table sort of summarizes the 3 types of CMK that we talked about earlier. So as I said, when you create the CMK, you can say that, hey, I want to create the CMK and I want to manage it, meaning that you take the responsibility of creating it and making sure you define a policy to control who can access to that, what they can do with that, and defining the key rotation policy and all those things. AWS provides you the control, but it doesn't do anything, and it lets you be the one who's solely responsible to do that. But compare that with the AWS managed key. Those CMKs are created and managed by AWS on behalf of some service that you use. For example, maybe you're working on an S3 bucket and you're saying that, hey, some very sensitive information is going to go into that S3 bucket. And at that time, you can say, okay, I'm going to, by the way, leverage the KMS service so that all the information that's going to go into that bucket is going to be encrypted. And only so-and-so user will have access to either encrypt or decrypt or both, or all those things you can define. But that is something that you trigger from the respective service, and the respective service can use can actually do all those things. Instead of using actually the same example, right, can be actually you can use a customer managed CMK to do that job as well. If you want to secure or encrypt all the data into a S3 using the customer managed key, you can do that. That's what the third row shows here. AWS service provides an option to integrate customer managed CMK as well, or you can use AWS managed key as well. And the way to differentiate is all the keys, the CMKs that are managed by AWS will have the AWS service name preprinted to the key. Such as if it's an AWS S3 that you're dealing with and asking for KMS service, the key that gets created by the AWS infrastructure would have AWS/S3. In this case, I think Redshift is being shown here. So, and there is no charge for AWS owned and AWS managed key. So AWS owned key, there's a subtle difference. There are certain service, when you enable encryption, AWS uses its own key, and the same key may be used across multiple accounts or for all accounts. You don't have access. You can't manage it. You can't track it. It's all taken care by AWS. So the service itself would not cost the customer with anything as long as they use AWS managed CMK or AWS owned CMK. The customer managed CMK, there is a charge to that, beyond the free allowance they give. So you have to make sure that you keep a tab on it whenever you use a customer managed CMK. All right. Any questions so far? Okay.
So one quick question. So the AWS managed CMK, the owned CMK, the key difference is that on the AWS owned one, you will not have any access to what encryption that they're doing, what type of encryption. You will not have any authority to change it. right?
Exactly. Yeah.
Okay, okay. So that's a different, but the middle one, the AWS managed CMK, you can still define the policy, right? Policy or the what key type you want to choose or no?
Correct. Yes, that's right. Yeah, AWS
Okay.
manages it on behalf of you. You can actually provide some high-level information,
Mm-hmm.
such as, I want to use this kind of encryption and all those things. I want to have
Yeah.
this
Mm-hmm.
key strength and all those things. But
Yeah, like
they will do it
let's
on
say
behalf
your
of you.
yeah, instead of like a 4K encryption, if you want
Correct.
to use a 2K encryption, which is speed up your application,
Correct.
and also like optimally encrypt, I mean, safeguard your service or data, then you can use the managed CMK. But in the
Exactly.
owned CMK, you will not have whatever AWS decide. That's the one they will be using.
Correct. That's right.
Okay, okay,
Yeah,
all right.
that's a
Thank you.
good one. Yeah. And in the AWS managed or AWS owned, they take the responsibility to periodically rotate them as well. As it's not a good idea to use the same key forever, right? So that is something AWS takes responsible of. All right. So moving on. So what you do is, as a first step, in case if you want to have a customer managed customer master key, you go to the AWS KMS console and go to the customer managed key and just click this create key. And when we see the demo, we'll see what are the steps. It's pretty straightforward steps that you have to go through to create a CMK. And as I said, you can only do certain tasks from the console, especially if you want to do any crypto related operations with the key. You cannot do that from the console. You have to use the CLI or the APIs or the SDKs. So we will see that how we can do that using AWS CLI, um, such as like how to create a data key and how to use that to encrypt, and how to um, use the encrypted data key and get the corresponding uh, plain text data key and all those things. So this slide we saw earlier. So as a first step, once you create the customer master key, custom managed from the console, you can use that to generate the plain text data key. And as part of that, you will also get a copy of the encrypted data key. So then what you do is you use the data key to encrypt using whatever encryption mechanism that you want to use using your application. You can use um, any of the publicly available libraries to do that. For example, OpenSSL or a GPG or anything, right? Any library that offers encryption, you can use that using this key, and that would result in a ciphertext or an encrypted text. So once you have that, you want to send that to the receiver, right? So at that time, you can throw away your uh, data key and the plain text, because you don't want to keep the plain text um, and the data key together, right? So now what happens when you have to decrypt, right? So um, the party who wants to decrypt, okay, so we already covered the encrypt part. So now I'll go to the next slide. So the party who wants to decrypt, so they will obviously have a copy of the encrypted data key. So what they will do is they would use the KMS service and provide this encrypted data key. And since they're authorized to um, use this KMS infrastructure, and since they are coming up with this encrypted data key, the CMK, the AWS KMS would use the CMK to provide the associated plain text data key. So this is another important service that KMS provides, so that now the receiver or the person who has received the cipher can have a way to get the key, right? So this sort of provides a meeting point for the sender and receiver to securely get access to the data key. So now once the plain text version of the data key is being provided by the AWS KMS, again, it uses the customer master key, customer managed customer master key here to provide the plain text version of the data key. So that's going to be used along with the ciphertext to get the plain text. I hope this.
Muthu, can I pause you for a minute? Sorry.
Yeah, sure, please.
Yeah. So if you go back to the previous slide, the one before that.
Okay.
Okay. So here you have the plain text data key and the encryption data key. Is this something similar to the public key and private key?
No.
Or is there something beyond that?
It's totally different. Yeah.
Okay.
So yeah, public key, private key, that's asymmetric key. So this example, I should have called it out. So here we are dealing with symmetric encryption algorithm. So this is just a single key, right? So we'll see that in the demo also. So now the goal is a sender and receiver, they want to exchange a secure communication, or they want to just, a person A in your organization, they want to send some data and they want to encrypt that, and they want to just put it in some place, right? So let's say, you are in HR and you want to exchange a message to, let's say, some other an employee, right? So what you do is you maybe an offer letter or anything. What you do is you go to the KMS and request a key, and when you do that, you get a copy of the key as well as an encrypted copy of the key, right? So what you do now is use the key and encrypt your message and send that encrypted message along with the encrypted data key to the employee, the one that you're sending the offer letter, right? So now the offer letter goes as an encrypted message, and now the employee has to, open the offer letter. All he has is an encrypted key, encrypted data key, and an encrypted message, right? So far, so good, Kanak?
Yeah. So there's two more questions on the panel if you want to quickly answer. If it's this is from Soy, is asking, how does the receiver gets the plain text key since the receiver can be outside AWS?
Okay. So that's a good question. So within the AWS, right? So you can actually provide access to, there's a thing called cross-account access. You can provide access to people who are outside of AWS, meaning outside of AWS account. Let's say you are in account 1 and you want to share that data with somebody else who is in a different AWS account, right? So that is possible. If you want to exchange this information outside of AWS, right? Then using this customer, managed CMK, you cannot do that. You have to do, this is something that is an AWS provided service, right? So if you want to communicate within an organization, within an AWS account, that's fine. If you want to communicate between two AWS accounts, that is fine too, that's possible. But if you want to communicate to somebody who's not leveraging the AWS service, this encryption, decryption is not going to work for you there. I hope, because you have.
So
like,
potentially.
Go ahead, sorry.
So that was exactly my question. So you have a sender and receiver, and if the receiver is outside of AWS, that means we cannot even use this mechanism of encryption and decryption, or?
Yeah, using this KMS service. Yeah, the KMS service is it's kind of you need to, as the slide shows, right? So you will get a copy of the encrypted data key, right? But in order for you to get access to the plain text, you need to use the AWS KMS service, because this encrypted data key is encrypted using the customer master key. So if you're an outsider not using AWS service, you have no way for you to leverage that service to the best of my knowledge.
But ultimately, it's just a plain text key, right? Can I just take it and send them via email or call them, and at that point they would have it, right? I'm just asking. I'm just
Yeah.
curious.
So when, when you do that, see, that's the man in the middle attack scenario, right? So let me go back. So the scenario that you're saying is exactly what is portrayed here, right? So now the eavesdropper can also get a copy of that key, and anyway, you're sending the encrypted data also, right? Now
Right.
they have both. They have both the locked message as well as they have the key to unlock that.
Right.
Right.
Right. Correct. Yes.
Yeah. So that's what is being addressed here using this. If you have a mechanism like this, so this is one way to do it, right? So
Okay.
when you use asymmetric, it works a little differently.
Correct.
And
Correct.
in the traditional e-commerce kind of application, you tend to use both together.
Okay.
We use
So,
combination of symmetric and asymmetric.
okay. So for the case that we just described, where the receiver is outside of AWS, the typical pattern would be to use the asymmetric keys in that situation, or
Yes.
okay.
Yes.
Okay. Sounds good. Thank
Correct. That's right. Yep. Yeah. I unfortunately I don't have slides for that, but yeah, you're right. So if you replace this with the asymmetric encryption algorithm, then I think what the scenario that you address can be covered there.
Okay, great. Yeah, thanks. That helps.
Okay. All right. So any other questions? Any other? Is it?
Yeah, I don't see any more question.
Okay.
Yeah, we can proceed.
Very good. Okay. So hopefully, I think so. This slide. Any other questions on this? Kanag, you were asking something, and this is, I think.
No,
okay,
we are good. I asked my question and you answered the Sai, and I don't see any more question on the chat window or Q&A.
Okay, good.
On
Let me
the
move on.
yeah, let's move on.
I thought I briefly deflected your question and went to Sai's question, but it's good. Okay. So envelope encryption, right? So we talked about envelope encryption, meaning that you can actually have layers or hierarchy of encryption. This slide just shows one level of encryption, whereby the data key itself is encrypted using the master key, but the master key is kept safely by AWS in their HSM fleet, hardware security module fleets. What you can do is you can add more layers of security. You can encrypt this master key with another key and that master key with another key, and that way you build layers of protection.
Is there any limit to that layers, or you can nest it as much as you want?
I believe you can nest it as much as you want, but I'm sure, like any other service, right, AWS will have some limit.
Correct.
And some cost associated with that, right? So that's something that would keep changing as AWS improvises and makes their service better. And but I don't have the number for you as to what is that limit.
No,
Sorry.
that makes sense. Yeah, thanks.
Okay. So here, this envelope encryption and action, we saw all those different things in 2-3 slides. Now everything is kind of consolidated into one slide. So you want to send some information to somebody in an encrypted way, or you want to just store some information at rest and encrypt it. So the way you do is use the KMS service, go create a master key. It could be anything, CMK, customer managed customer master key, or AWS managed, or whatever. So in this case, let's assume that it's a customer managed customer master key. So we get a copy of the plain text data key as well as the encrypted data key. So you use the plain text version of the data key to encrypt the data, right? The plain text and the plain text data key, you get a ciphertext. So you can throw away your plain text and your plain text version of the data key at this point in time. It's not needed. So if you want to store it, you store your encrypted data key as well as your ciphertext together at rest, or you can send, both to somebody, who wants to have access to this data that you want to securely communicate. So when you do that, they're going to get both of these. They will just take away only the encrypted data key and approach the AWS KMS, provide that encrypted data key, and they get the equivalent plain version of the data key. You use that, or the receiver uses that along with the ciphertext to get the plain text data. Okay, any?
On step 3, I got a little bit lost there. When we say plain text plus data key, we mean the plain text data key? Oh, I'm a little bit lost there.
Yeah, the plain text is the actual message that you want to encrypt here.
I see. Okay.
Right. So,
right.
So you see this plain text, and the key goes into the gear, the encryption algorithm, and that results in the ciphertext. That's what we have shown here. Ciphertext equals plain text plus data key that you're feeding through the encryption algorithm.
Okay. So there is no such thing as plain text key, right?
No, maybe I kind of confused you that. Yeah. So the data key is the plain text version of the data key. It's
okay.
Yeah.
Sounds
so you have a two version of the key. You have the plain text data key and the encrypted data key.
Correct.
So you want to protect the data key. So when you send the information, encrypted information to somebody, or when you want to save it, you always save the ciphertext with the encrypted version of the key.
Okay. So in step 3, when we say plain text plus data key, that is the encrypted version of the data key, or just the?
No. So this is the plain text version of the data key that you feed it to the encryption algorithm, right? So the encryption algorithm, it could be a simple, I'll give a simple example, right? So your algorithm, I hate to give a simple example like this. You guys must have heard of the Cipher, Cipher and all those things, right? So, or we'll do a simple shift cipher, right? So you have alphabet A to Z, right? So let's say you want to send an encoded message or an encrypted secret message to somebody. So you want to say, well, let's pick a 3-letter word, by, BYE, or even let's simplify that, by, BI, right? You want to encode and send it to your friend. Okay, so what you do is, since you're dealing with the English alphabet, you say that I want to shift the letters by 10 letters, right? So that's your algorithm. I mean, shifting is your algorithm. Your friend will know that he has to unshift, and the key says shifted by 10 letters, right? So the algorithm is, everybody knows, but the key, you're shifting it by 10 letters, is the key that you're using to create that secret 2-letter word, right?
Makes sense.
Yeah. Now when you send it to your friend, you want to encrypt the key, is that shifted by 10 letters, right? So that you want to encrypt. So that's this version of the key.
Okay, got it.
Sorry for this crude example. So
No.
all right. So this is going to be the last slide, and we'll jump onto the demo. Okay, so there is this notion of client and server-side encryption when you deal with AWS, right? So it's pretty straightforward and simple concept. So client-side encryption means let's assume that you have an application that is either in on-prem, or it could be in AWS. It could be any combination of those things. That doesn't matter. All you're saying is, when you say client side, I am going to encrypt everything, and I'm going to send the cipher text as an encrypted message to the receiver. So it's all done at the client side itself. The client side takes care of creating the key, takes care of somehow sharing the key to the other party and all those things. It doesn't matter. So, but the encryption, the key thing is encryption is all done on the client side. And when you send it, you could send it through a clear channel like a regular HTTP, or you can use a TLS channel to send that data, and it gets stored here. But compare that with the server-side encryption, right? So the client sends only the plain text data. And, as the best practice says, you don't want to have clear text information sent in the communication channel, right? So it's recommended to use a TLS or a HTTPS channel. So that way you provide security in transit. Everything is encrypted when you send it. And the data is going to be decrypted. But before it is saved directly, you want to use KMS service to encrypt and save it there. So this is the concept of server-side encryption, SSE. Is that clear? It's a pretty simple concept, but
Yeah.
Just to reinforce that.
So the whole encryption then happens only on the AWS area, right?
For the SSE, correct.
Okay, sounds good. Okay, thanks.
That's right. Yeah. Okay. So now we'll jump onto the demo. So the demo would be pretty simple demo. Let me just go to my console. Okay, I've guessed it. I got kicked out and I'm logging back in. So let's do some simple test. Okay. So as I mentioned, most of the things that you want to do with AWS KMS, you have to either do it through AWS CLI, or you do it through, through API SDK. Okay, for this demo, we will use a AWS CLI to do that. So what we are going to be doing is, let me just quickly jump out to the slide, and we'll do a simple thing. We'll go to the console and create a CMK, right? And then we'll use AWS CLI to generate a data key. And in that process, as we saw in the slide, we will get an encrypted copy of the data key also. We'll save them. Then I'm going to use an OpenSSL library to encrypt a file. Okay. So in this case, I'll be the sender and receiver. Okay. So just to keep it simple, right? So I will encrypt a data file using the key that CMK has provided, and we will store the encrypted file. So now I can safely delete my plain text data as well as the plain text version of the data key. Now I'm going to assume the role of the receiver, and I receive the encrypted data. Now I need to somehow find a way to decrypt that message. So I'll use AWS CLI to get a copy of the data key, the plain text version of the data key, by providing the encrypted version of the data key. And then I'll use the OpenSSL library to decrypt that file. Is that flows?
Yeah, that makes sense.
Okay.
Yeah, Muthu, can I ask one quick question? So
Sure.
this is totally different from the CMK, but I'm kind of trying to understand this clearly. So when you set up a VPC and do instances, create instances, like on the instances you're trying to SSH from your laptop or something,
Yep.
then you create a key, right? SSH key. Using that key, you're logging into your instances, right? And I mean, logging means you're SSHing into instances, right? And then those keys, when you create instances, is you create a key also, right? The private key, public key, and that won't come under the CMK at all.
Not at all. Though those
okay.
are
So this is okay. So this is basically between the applications.
Exactly. Yeah.
Okay,
Two different orthogonal things. Yeah. Exactly.
Okay.
Yeah.
Okay. Got it.
Okay.
Just want
Yeah.
to make
This
sure.
is for your application data that you
Right.
want to store it, in some.
Got it. So
Yeah.
this is just purely application. It's not like accessing the instances or anything.
Correct.
Okay.
That's right.
All right.
Yep.
Thank you.
Okay. All right. So now what we want to do is we want to just go create the CMK. So I'm going to go to the KMS console. Okay. I already have a key, right? So as a owner of the key, I can actually delete, enable, disable. Okay. So I'm going to go delete it, just to show you guys, how to delete this. But it's going to take some time. It's not going to get deleted. I'll just say they give a 7 to 30-day time. So I'll say schedule it. So now it goes into the state. This is, I just want to have a clean slate, but it's going to take some time. So let's not worry about it. So I'm going to go create a key. So this is the first step, right? So the first question that AWS is asking is, hey, you say you want to, okay, before that, right? So we also said that we are going to create a customer managed key. So it's a CMK, customer managed, customer master key. So now we are posed with a simple question. Do you want to use a symmetric or an asymmetric encryption algorithm? So as we saw in the demo, as well as in the slides, I mean, the demo flow slide, as well as in the other slides, I'm going to use symmetric encryption algorithm to keep it simple, right? So there are some advanced options, you can just ignore it. We'll just leave it to the default. Okay. So the first important thing is, we need to give a alias name for this. So I'll say ATM demo. Okay, that's the alias name for the key. You can just give some descriptive name. Okay, so you can add tags and such, the standard stuff. So I'm not going to do that. So this is a very important step. So this is where, you as a AWS account owner, you define the control of this key. You're creating it, but who else can manage this? Who else can administer this key, right? So you may have in your organization, some teams and some IAM user. You can actually delegate that responsibility to them. I'm going to just leave it for now. The kind of account that I have, put some restrictions. So that's why I'm not showing. But when you guys practice, I strongly encourage you to create some IAM user and designate them as an administrator, and you provide this capability to some of those IAM user who has admin privilege. And more importantly, in the next step, step number 4, this is where you define who gets to perform crypto operation using this key. Who can generate data key, who cannot, who can encrypt, who can decrypt, and all those things. So again, I'm going to skip it because I'm going to use my own account to do everything. So when you guys practice, I encourage you to do that. So this is another important thing, right? So we talked about how you can actually provide access to cross AWS account. So you do that by adding another AWS account here. So if you click that, and you can add the on the AWS resource name to add it. So I'm going to just click next. I'll just remove this. So finally, it shows me, what sort of policy that is going to be associated with this particular CMK that we're creating now. I'll just say finish. So now, as you can see, we created this ATM demo, right? So pretty much, most of the other things we are going to be doing, we are all going to do that from the command line. So I've already created my, I've already set up my AWS CLI on my laptop. You can see the terminal screen I'm sharing, right? Okay. So what I did is I did a simple AWS CLI, command. I ran a query saying that, hey, AWS, I want to see the list of keys that are created. So you can see that, we have 2 keys that have been created. That's what is shown here. One ending with DCC2, that's going to get deleted, if you see the alias, right? The next one is the one that's ending with 317C. This is the second key that I have in my KMS console here. So if you want to see the alias name, you can just use this list aliases, and you have this alias demo and alias ATM demo keys that are shown here. So now, next what we want to do is, let me see. Give me 1 minute. Okay. Oops. Okay. So I'm going to just delete everything. Okay. So I just want to have a clean slate. So as you can see, I don't have any files, right, in this directory. So first I'm going to create a data file, right? So let's say this is the file that we want to encrypt. Okay, as you can see on the VS Code on this, we can see that a file got it popped up there. I'll say I want to just create name Muthu, and let's say I want to encrypt this. Password is password. ID is 1, 2, 3, 4. Let's assume that we have something like this that we want to encrypt. So I have this file. So this is the data file. Okay. So now, as a first step, as you can see, what we have to do is, we already created this CMK, right? Now we have a file that to generate a data key, and we want to use the data key to encrypt it, right? So you all can hear me okay?
Yes, we can, yeah.
Okay. So now what I'm going to do is I'm going to use this command, okay, to request a data key. But when I request it, I have to make sure that I use the right alias. The alias that I'm going to use is ATM demo. So if you recall, we have two keys. So this one, demo key, I've scheduled that for deletion. So I'm going to use this ATM demo key, right? So all I'm saying is, hey, KMS, generate me a data key using the key ID, customer master key, that has the alias name of ATM demo. And I want to use a symmetric encryption algorithm, AES-256. And this whole KMS it's not a global infrastructure. It's kind of tied to a region. And you have to say in which region you have, created this key. My account can perform things only in this US East 1 region. But if you all have a free tier account or some other account that may not have that restriction. So now I'm going to just run this AWS command to generate the data key. So once I do that, I'm getting a JSON response back for this command, and I get a plain text version of the key, right? As well as I get a blob, a ciphertext blob. This is the encrypted version of the data key. So if you recall, this is the step. We are at this step. We created a key and we asked for a data key, and KMS is providing us with a data key and an encrypted data key, right? So now going back to the slide, what we want to do is we want to encrypt the data. But before we do that, there is one step that we have to do. We have to take the key. It's whatever we are seeing here is encoded in base 64. So now we want to decode that. So I'm taking the plain text version of the key, right? I'm feeding that to base 64 and the tool, and I'm saying that, okay, decode that, and I'm going to save this as a data key. Okay. So now let's see what happens. So I'll also keep this. Now, right now we have only a data file, right? This is what we just created. Now I'm actually creating a data key. We can see data key, this key cannot be, you cannot see that. So now what I'm going to do is I'm going to create a decoded version of the encrypted key as well by doing the same method. I hope this is not confusing or it's clear what I'm doing.
Now you're using base 64 to decode, but we encode, we never used base 64. That's what's, as far as I can see, or maybe I missed it.
No, see this JSON output, right, that we got. AWS, what it does is it takes the key and it encodes it in a base 64 format.
I see.
And we have to, before we can use the key to encrypt, decrypt, we need to, decode the key.
Right, to base. Okay. So internally it does the basis for encoding, and that's why you have to do the decoding.
Exactly. Yep. This is all documented in the AWS, if you see it, right? So in the documentation, it will clearly say that, the key that we will get when we run the AWS CLI is all encoded with base 64, and they will ask us to decode it before we use it.
Okay, thanks.
So now we should have three files. We have the original data text file, we have the data key, and the encrypted data key. The next step is now we want to encrypt the data file using some kind of an encryption library. I'm going to use OpenSSL library as I mentioned during the discussion, right? So I'm just taking this command, cheat sheet that I just prepared for myself. So OpenSSL is a library. It provides you, lots of, it's like a Swiss Army knife, right? You can use that to encrypt, decrypt. You can use that to use against a symmetric or an asymmetric encryption algorithm. In this case, we are going to do an encryption function using AES 256 key. And what we are saying is we are going to use the input file to be encrypted as data-file.txt. And I want that to be encrypted and saved in an output file with the name encrypted data file.txt. Using this AES 256, and the key file that we want to use is data key. And they want you to use this ITER key. OpenSSL has some issues, and to overcome that, they want you to use the ITER key, which iteratively uses it to encrypt multiple times essentially. So once you do that, you would be having an encrypted data file. So this is the file, right? So if you try to open that encrypted data file, it'll be garbage. You cannot make anything out of it, right? So now we have done 3 steps. We created a key, CMK, then we requested a data key, and we use the data key to encrypt the file. So now I'm going to assume myself as the receiver, and I'm going to delete this data file. Okay. This is the text file. I don't need it. I'm going to delete the data key. Okay. All I'm left with is encrypted data key and the encrypted data file. So far, so good, folks?
Yes, Muthu.
Yes, we are with you. Yeah.
Okay. So now we have to make a call to KMS, right? And we have to request the version of the key, the plain text key that we can use to decrypt the file. So the file to be decrypted is encrypted data file, but the data key that we have in our hand, being a receiver, we received a copy of this encrypted data key. So all I'm saying is, hey, AWS KMS, help me decrypt this blob, right? Encrypted data key, okay, using the CMK that's in my account in this particular region. So as part of this, I will get a copy of the plain text now. So far, so good. So you see the difference.
Plain text key is the same as the one we did before the decode.
Exactly. Yeah, that's
Okay.
it. You can see it, right?
Yeah. Okay.
Right here.
So that comes out from the KMS now. Okay.
Exactly. Yep. This is the important step. Yep. So now I'm going to decode this, right? Because it's in base 64 encoded, I'll say put it as a data key. So now I'm left with 3 files now. I've got an encrypted file. I've got an encrypted key. Using the encrypted key, I got a plain text key also. So now last step. So I'm going to use the OpenSSL library again. This time I'm going to do a decryption. Okay. So the input file is an encrypted data file. Output is unencrypted. It's a new file that I'm creating, right? Maybe I'll just change it to, I don't know why I had .text one. So as you can see, I'm using a -d flag now for decrypt using the data key. Okay, now the idea is we should get the unencrypted data with that 3 lines that we had earlier, right? Going back, I don't have any unencrypted data here now. I have the unencrypted data, and this is what we had to start with, right? Any questions? This sort of concludes the demo. One demo that I wanted to give. This is a longer version. There is a shorter, simple version that you all can try. When you practice, just go to S3 bucket and enable encryption. When you enable encryption, right? I can just quickly walk through you guys. So any questions on the CLI demo we did?
No questions, just an observation. Like when you share the video, do you mind sharing the PowerPoint too? Because we use a technique called edit on copy. So
no. Certainly. I think Aru has been doing. I don't know. I think he has been sharing.
Yeah, I don't think it's posted anywhere. It's still recorded, but I don't think.
That can be. That's not a problem.
Okay, that would be helpful because to go slowly, it will be very helpful.
Yeah, sure. So you guys can do the same demo in a simpler way as well. I took the longer route to make sure that I kind of reinforce all the concepts. So here in this way, you can actually use one of the servers like S3, which uses KMS, right? And you can create a bucket. And when you upload when you create the bucket, you can just go define saying that you want to use encryption, right? So here I have tied that with, probably I can edit here because I'm using. So here you can see that you want to enable the encryption, and you want to use the AWS KMS service here, and you want to use a key that you have created. So I'm going to delete this key and see if I can pick up my right. So I'm going to pick up this key and save changes. So once you do that, then you can upload your file, and you can what you can do is you can do some negative testing, right? So you can upload a plain text file, then you can make sure that it gets encrypted, and you can log in as an IAM user who doesn't have access to this KMS key, and they will not be able to open that file. Then you create another IAM user who has access to this KMS key, who can encrypt, decrypt, and only that person will be able to see the file unencrypted. So you could do that. So this would be a much easier way to test it, to see how KMS works. So that sort of concludes the KMS part of the thing. If you guys are up for it, I can just go and cover DNS Route 53, or we could. I will not be able to show the demo. I can just only talk about it, or we can table it for next session and have demo as well.
Yeah, how long we have right now? It's 10:30, so we started at 9:15.
I know we are already. I was hoping. I'm pretty poor in managing.
That's fine. If people.
Actually, it was very good. I feel, in my opinion, I think that pace was perfect. In my opinion, so
yeah,
I think we'd rather learn slowly and properly than rushing through things. That's just
Yeah, like the other people are listening, Muthu. Should we park this for next session, or we can go ahead? And the few other people are silent, so we do not know. I have Soba, Saravana Kumar, Parani, Murugaya. If you guys want to continue with the Route 53, the DNS thing, we can continue, or we can park it for next session.
Yeah, this is yeah. So hey, this is sorry.
No problem, no problem.
Yeah, this is Saravana Kumar here. So like, what my thought was like, since the demo will not be today, as I heard, so I would suggest to do it next week with the demo. That way, after we after we get some kind of idea, then
Yeah, I don't think we can even show demo next week because he's using one of the student account. I don't think he has access to.
No,
Okay.
actually,
right, Muthu?
actually, I have kind of worked out with Aru. So
Okay.
that is one of the reasons. Yeah, I will work with Aru and will use Aru's account to do the demo.
okay.
Okay.
Yeah, with student account, I can do the demo. Only thing is I don't have a domain, but Aru has a domain. So, so we can use that to create records and things like that. And yeah.
And I have other couple of quick questions. Can I ask now?
Yeah, go for it. I don't know if I can answer, but I'll try.
Okay, no, like, so actual thing is like, I'm kind of a beginner to AWS first thing. So like, I want to, so I am, trying to understand many concepts nowadays, but instead of even if we are whatever we are hearing to learn the concepts, it's better to have a hands-on experience. That way we can play around in AWS. That's my understanding. So if that could be the case, like, what is the best way to do kind of a hands-on experience? I know like we can create an account and we can play around, but I don't know how. If I create an account, I don't know, like, do we need to provide our credit card information and all those details? And if we didn't handle it properly, I mean the services properly, they will charge in the background. Correct me if I'm wrong.
Yeah, that's a good question. I had the same fear, when I started out also, right? But as you rightly said, there is no way out, right? So there is no escaping. You have to provide the credit card, and you definitely want to have the account created so that you can get hands-on. That's the only way that things will stick in your mind, or else you can spend any number of hours by reading and watching some YouTube videos, and it's not going to stick in your mind. So it's important to get hands-on, and it's important to get a free tier account, and they will let you do it only when you share the credit card. But you can be very disciplined, right? So when you learn about a service, just try to understand how the billing works also. It's a learning experience also. And you have to be a bit diligent and disciplined. Make sure that you clean up whatever you're doing. Once you're done, just clean up all the resources, and that's how I've been able to. I think so far I've paid only like $1 or $2. That's it. Sometimes I forgot to shut down something, and I quickly realized, and the past year or year and a half, right? So that's pretty good, right? So I don't mind mind that at all. So
Muthu,
No,
in the
like,
same way, like I hear what Saravana and Kumar is saying, but on the AWS console, so when you are playing around, right, on the AWS console, is there a place where you can go and see, okay, so this much money I'll be charged if I don't do any, cleanup or anything? Is there a way where you can go and
no,
probably?
it won't show you that, hey, you're running so and so resources. If you don't clean up, we're going to charge you. It won't show that information. It will, for any service, right? Starting with EC2 or anything, it will say, okay, there would be a billing section. It would give you some, documentation as to how they, maybe I'm preaching the choir. I know probably you guys may be aware of this, the documentation that I'm talking about. So you can go through the respective service. Let me see if I can pull up, right? So give me 1 minute.
Yeah, I think that's one of the fear. Saravan has it. I play with the company accounts. I usually don't look into those, but
No,
I
it's a
hear like
valid.
as an individual. Yeah, so we don't want to get charged, right? Like our old telephonic way.
Yeah.
Like they used to
So,
charge $1,000 when you call India.
for instance, right? Yeah, go ahead.
Sorry to interrupt. So, one of my colleague, so this is Sarana Kumar again. So, one of my colleague, he told me there is a kind of a Linux Academy. So, third party, like they will, we can open, we can create an account in Linux Academy, and we have to pay like $50 per month, and we can make use of some of the service, and some of the service will be enabled if we approach them. I mean the Linux Academy, and play around in AWS. That is one of the option my colleague was talking about. So do you guys familiar with those, like instead of creating a free account and provide all the credit card information, if we have kind of any channel to do these play around, that I feel like $50 monthly, $50, yeah, that is okay for me.
No,
So
the thing is, if you're willing to spend $50 a month, right? As I said, I used to have a free tier account. I just closed it. For a year or year and a half, I paid only like $2 for the whole duration, right?
oh, is it? Okay.
Yeah, you just have to be a bit disciplined. We are so afraid of sharing your credit card, but Amazon is
Yeah.
really good.
No, actually, Muthu, it's not the upright to give a credit card, but the problem is you do not know what you will be charged. I
Correct.
think
That's
that's the
true.
one fear, right?
Yes,
So
yes.
if there is if you can point to a document that says how the billing will be done, that will be easy for him and to go read it and then understand the billing structure. Then you won't be feared.
Yes,
Yeah.
that's right.
For example, right? So let's go to AWS. Let's say EC2, right? So you go to AWS EC2, right? They will have a pricing section, right? So for every service, they will have a pricing tab that will clearly explain how it's going to be charged. So you just have to, before you want to learn EC2, right? Just take a minute or two, or maybe take 5 minutes to go through this page and understand how the billing works. Then you jump into the EC2 console. That's all I would recommend. That's what I used to do. And it's a good learning. When you go up here for some interviews, right? I heard sometimes people ask about how a service is built and all. So you're being forced to learn that also. So you go to any service, right? You will have a tab for let's see. Let's go to.
There's a pricing calculator also, right? That we can use. And
Pricing calculator, I'm not sure. I know that if you go to the console, right? So they have a billing, console. So the billing console can be used to track your usage. And it'll also give you some prediction. Okay, at this rate, you're going to be using this much and all those things. It'll give you some forecast data. But I don't know if there is a billing calculator. I think is R around, or maybe we can ask.
No, R is not here.
Okay.
But I think this is what probably Saravana Kumar may want to check often, like when you go and play around. So probably just go to this section of this billing and see how much the dollar is trying to charge you, right?
And
Then
one other thing is just search for AWS free tier, right? So the very first link you get, they will actually list out the policy for all the different service, how much they charge for each of them. So this is another source that you guys can use to get some high level understanding, right?
Okay.
Yeah.
But I mean, we have to jump into this, right? Just don't be afraid of this. Just bite the bullet. Be a little bit disciplined. Spend some time ahead of the time. Understand the billing structure of a service that you want to play around, and I think you should be good.
One last question regarding the same thing. Like, so is it kind of a what is it? Is it anything that we can put a kind of a if my credit card billing reaches $25,
Yes.
can I
Yes.
stop
Yes,
using
you can do that. Yep.
Okay.
That I know you can do it. You can actually say that, hey, I want to be alerted the moment I cross $1 usage.
Okay.
Something like that. You can actually go define your thresholds.
Okay.
You text me and all those things. Yeah, you can do that. Yep.
Okay. Got it. Okay. So I have one more question. Sorry. Last question is like, so nowadays, like AWS certification, if I want to do AWS certification, like earlier, some of my colleagues were, they used to do, they will register, they will make the payment in online, and they will go for to any one of the nearest center to do the AWS certification. But is it anything like online certification nowadays is happening? Is it possible? Because since it's a COVID situation, any idea about that?
Yeah, I'm not taking the certification myself, but I heard that they are offering online is what I heard.
Oh, is it? Okay.
I may be wrong, but maybe Kanag or we can, if Kanag knows, please go ahead and clarify, or else we can ask.
I don't know either. I haven't taken one myself.
I know Cisco offers some certifications online, so.
But that's a company paid one.
No. Cisco certifications, right? You can go to Pearson VUE and you can take it online, not just for employees. It's for
Cisco product certification.
So
yeah.
Pearson,
Okay.
Pearson
That
VUE,
that people know. Yeah.
I have taken Pearson VUE virtual for Azure, so I'm sure that the AWS also they will support, I guess.
Got it. Yeah, makes sense. Yeah.
So who is that? Can you please repeat?
This is Kumar. I have taken Azure certification virtually with the Pearson VUE. So if AWS is certification is on the same Pearson VUE then provider, then I think they should be able to support it as well. So
yeah, it's confirmed. I just did a quick search. You guys can see the screen, right?
Yes.
It's offered virtually.
Okay. Cool. Okay.
yeah, all you need is a camera and a clean desk.
Okay. Got you.
All
Okay.
right.
Thank you.
So Muthu, do you think we can stop here and park the Route 53 for next session?
Sure, Kanak. Yeah. Thank you, everybody.
Yeah.
Thanks a lot, Muthu.
All right.
Thank you, guys.
Have a
Yeah.
good
Thank
day. Bye.
Yeah. Bye-bye. Muthu, stop பண்ணிடுறீங்களா ரெக்கார்டிங்க?